In this video, we'll take a look at notes for sections 3.3 and 3.4. Section 3.3 is a reminder of what a rectangular coordinate system is. So let's take a look at a rectangular coordinate system has an x-axis, that would be the horizontal axis. So it has an x-axis, and think of it as just a number line, starting with 0, counting by units 1 through 5, and then negative. And it actually goes on forever. So the x-axis is the horizontal axis. The y-axis is the vertical axis. Same, it's like a number line except a vertical number line. The origin is where the two number lines intersect, and they intersect at a coordinate 0, 0, x equals 0, y equals 0. So that's the origin. These two number lines that intersect at 90-degree angle split into quadrants, and we identify the quadrants counterclockwise. So the first quadrant is where your x's and your y's are both positive. The second quadrant, your x coordinate is negative, y coordinate is positive. Third quadrant, both your x and your y coordinates are negative. And then the fourth quadrant, x coordinates are positive, y coordinates are negative. And the coordinates themselves are listed as points x comma y. So if you take a look at the points that are graphed, point Q, point P, S, R, they tell you where to travel from the origin. So if point Q is negative 2, 3 from the origin, we count negative 2 on the x-axis, up 3 on the y-axis, and that's where our points are. So if a point is on the y-axis, such as point T, that means the x-coordinate is 0, and then the y-coordinate in this case is 3. If your point is on the x-axis, then this point would have an x value of negative 3, but the y-coordinate would be 0. So those are like x and y intercepts, or points that are on the x and y axis. So just a review of the coordinate system. The example that we'll look at is 3 vertices of a rectangle are A equals negative 3, negative 2, B 4, negative 2, and C 4, 1. What is the fourth vertex? So we'll have to draw and see if we can figure out where the fourth vertex is. So the point A is negative 3, negative 2. The point B is 4, negative 2. Point C is 4, 1. So 1, 2, 3, 4, up 1. And then, so there's a start of a rectangle. So that last point is going to have to be right here to make a rectangle. So where would that be? That would be at the x, negative 3, and a y coordinate of 1. Okay, so there's where the fourth vertex is. Then example 3, how to locate sets of points. It says, where are all the points whose y coordinates are 2? So if we draw an axis, y is the vertical axis. So all coordinates, y is equal to 2 is right here. So all coordinates whose y is equal to 2, it doesn't matter what x is, the y coordinate is 2. That means they would lie on that horizontal line, y is equal to 2. So where are all the points whose y coordinates are 2? They are on the horizontal line that crosses the y-axis at 2. Then last example out of this section, where are all the points x, y for which x is less than 0 and y is less than 0? So if x is less than 0, it's negative. If y is less than 0, it's also negative. So where are all of our coordinates that have negative x's and negative y's? If we look above, all of those points would land in the third quadrant. So the answer to B is quadrant 3. All right, that's section 3.3. So we'll go ahead and continue in this video for section 3.4 as well. Section 3.4 is graphing a function. There are many ways to graph a function, and different types of function have specialized ways to graph. In this section, we're going to take a look in general how to graph a function by plotting points. So if we want to graph the function f of x equals 3x minus 5, that's actually the graph of a line. Y is equal to 3x minus 5. So if you were going to graph the line using slope-intercept method, you would start at the y-intercept -5, and you would count up on the slope to get to the next point. So we know from previous chapters that that is a line, but what we want to do is go ahead and plot points just to show you that we will end up having a line. So f of -2 means substitute -2 in the function. F of -1 means substitute -1 in the function. And then substitute each of these values to figure out what y is. So for the first, f of -2, 3 times -2 is -6 minus 5 is -11. So when x is -2, f of x is -11. Next, we take 3 times -1, we get -3 minus 5, which is -8. Next, we have 3 times 0 minus 5, which is 0 minus 5, which is -5. 1, we have 3 times 1, which is 3 minus 5, which ends up being -2. And last, 6 minus 5, which equals 1. So if we were going to graph that and graph the points, we've had from a previous lesson that graphing the points, you really only need 2 points to make a line. So we'll make let's see, let's graph some of the ones that are a little bit easier to fit on there. 0, -5, 1, -2, 2, 1, and you'll notice our y-intercept is -5, and then just to reinforce, the slope is 3. That means count up 3 to the right one. And we connect our points, we end up with a straight line. So we knew that because we've worked with lines before, and we know they're in that form where we have x to the power of 1. All right, the next one we're going to graph has 2x squared minus 4. So if you haven't had quadratics before, you might not be quite sure exactly what this is going to look like. So if you've worked with quadratics, anything with an x squared is a parabola of some sort. That means it looks like this or like this. If the number in the front, 2x squared, is positive, then your parabola will be pointing or curving up. So this is just to keep in mind. I know that I want my graph to look like. So now I'm going to plot some points. If we substitute -2, we get 2 times -2 squared minus 4. This is going to take a little bit more work. So we get 2 times -2 squared is 4 minus 4. 8 minus 4 is equal to 4. So the first point is -2, 4. Now we substitute a -1. We get 2 times -1 squared minus 4 is 2 times 1 minus 4, which equals -2. So when x is -1, we get -2. Third point, 0, f of 0 gives us 2 times 0 squared minus 4, which would be just -4. So we get 0, -4. Substitute a +1, and what happens, we get 2 times 1 squared minus 4. We end up with the same thing we got when we put in a -1, because when we squared the -1, we got positive. So we end up with a -2. And that's going to happen when we put in 2. Not in every situation, but in this situation, we'll get the same thing. We'll end up with 4. There we go. Make sure my points are in the right place. I think I had it in the right place anyway. There we go. Sorry about that. That was in the right spot. So when we connect our points, we get a curve this time. Okay, so that's our graph of f of x equals 2x squared minus 4. All right, next item, recall the definition of a function. A function is a relationship between two variables that for every value of the first, there's only one corresponding value of the second. And what does that mean if we have a graph? If we have a graph, we do something called the vertical line test. The graph of a relation also represents a function if and only if every vertical line crosses the graph at most once. So if we look at the parabola that we just graphed, if you were to draw vertical lines anywhere, it would hit the graph exactly once. So this is a graph of a function. For every x, there's a one y. Okay, and then another idea that we've done in a previous section is domain and range. The domain is the set of inputs, all the x values, independent variable, and the function of a function, and the range is the set of all the outputs, or the y values of the dependent variable. So we looked at that in terms of equations, but now we're going to take a look at it in terms of what the graphs, if you have a graph of a function, can you tell what the domain and range are? So we'll take a look at these 4 examples. The first one is a parabola, similar to the parabola we had above. By the way, if you look at all 4, they all pass the vertical line test, so all of them are functions. So maybe before we do that, what would it look like if it didn't pass the vertical line test? If you had the graph of a circle is not a function. It doesn't pass the vertical line test. And what that means is the vertical line or x values, it would hit the function in 2 different places. For that x value, there are 2 y's, not just 1. All right, so let's identify domain and range of each of the following. Domain are the values of x. So consider these with arrows on the end, which means they go on forever and ever. And you look at your x values. 2, is there a coordinate on the graph that corresponds to every x value? And since this goes on in either direction, then all real numbers, or the interval from negative infinity to infinity, or all real numbers, would be the domain. So you can put anything you want to in there for x, and you'll get a y value out. The range are the y values. Notice that this graph doesn't cover the entire y-axis. Its lowest value is -3. So it has a value for y everywhere from -3 above. So the range includes -3. -3 to infinity is interval notation, or you can write that as y is greater than or equal to -3. So the domain is all real numbers. The range is y can only be greater than or equal to -3. The next graph, again, think of arrows on either end. This graph extends forever in both directions. So not only is the domain all real numbers, so is the range. Next graph, our graph starts at the point 2, 0, and then increases from there. So the x values are only the values from 2, x greater than or equal to 2, or you can write that as all the values that include 2 to infinity. Okay? The y values with the y-axis start at 0, since this is the point 2, 0. So the y values are from 0 to infinity, or you can call it y is greater than or equal to 0. Last example, we have kind of half of an oval here, half of an ellipse. Our graph starts here and ends here. So what x values do we have on our graph? And this is everything from -5 to 5. So we can write it as x is between including -5 to 5 as a compound inequality, or interval notation, -5 to 5. Y values start at 0, but the highest y value is 3. So the y values are between 0, including 0, and 3. Or interval notation, all the values between 0 and 3. So that's how to take a look at a graph and figure out domain and range.